All right, thank you so much for joining us today. And in this video, we have like 5 questions that we are going to go through together, right? So stay here with me. Now, the first question is we want to find y prime and y prime prime. So let's just look for y prime and y prime prime, right? So y prime is going to be 3x squared plus 12x plus 9. That is just y prime, right? And we can just try to do the factorization because we are going to use it. So I can factor 3 out, x squared plus 4x plus 3. Let me try and factor. This is the same as x squared plus x plus 3x plus 3. And then this is x out, x plus 1. This one I can factor 3 out, x plus 1. So 3x. Here, when I factor x plus 1 out, I'm going to have x plus 1, then x plus 3. So this is what I'm going to get at the end of the day. Okay. Now, what is y prime prime? Y prime prime is when we differentiate y prime. So this was the results. Let's try and differentiate that. We are going to have 6x plus 12, right? So this one too, we can factor 6 out and then x plus 2. So this is what you're going to get. So this is the a. So a, we have y prime to be equal to 3x plus 1, x plus 3, and y prime prime is equal to 6x plus 2. All right. Now b is determine the intervals where y is increasing. So for us to determine where the function is increasing, we need our critical values. So where can we get the critical values? We can get it from the y prime. So critical values is the one that's going to make y prime 0. So x is equal to 1, s is equal to minus 1, and s is equal to minus 3. These are the critical values that's going to make the point or the y prime to be 0. So let's try and indicate this on the number line. Minus 3, minus 1. So don't forget here we are using y prime. So I need to pick any point here and plug it in what? Y prime. So y prime of -4, y prime of -2, and then I can pick y prime of 0. Right. Or let me say y prime. Yeah. Let's use y prime of 2 and see what you are going to get. So let's do that. Let's plug in 4. -4 here is going to be negative. -4 here is also going to be negative. Negative, negative will be positive. So this one will be greater than 0. So this one will be positive and then increasing, right? Positive and increasing. -3, this one will be 0. No, -2, this one will be positive. This one will be negative. So positive, negative will be negative. So this one will be less than 0, negative, and this one will be decreasing. Let's look at the last one. 0, when I plug in 0, all of them is going to be positive. So this one is going to be greater than 0. This will be positive and this will be increasing. So what is the increasing interval? It's just at this point and at this point. So increasing interval is negative infinity up to -3, and then from -1 to positive infinity. That will be the increasing interval. So C is looking for the decreasing interval, which is between -3 and -1. Good. Now find and classify each critical point. So we have already found the critical point. So the critical point is x is equal to -1 and x is equal to -3, right? Good. So that is what you are going to get. But basically, when you say critical point, mostly we need 2 coordinates, but I think this one is what we just need here. Now we need to find the local max or local minimum. So what will be the local max? Local max is where we have increasing and then decreasing, plus and minus. So this is where the local max will happen. So the local max is at s is equal to -3, and then the minimum is at where we have minus and plus, right? So the local minimum is at s is equal to -1. Good. So that is the D. That is the D. Good. Now E is determine the intervals where y is concave up. So with the concave up and down, we need to use the y prime prime, right? So whilst we are using y prime prime, we need to find for what is called point of inflection. So here is 6x plus 2. So we need to look for x value that will make this one 0. So that is when x is equal to -2, right? So that now we can put this one on the number line. So -2. So let's pick any point here and plug it in this, and then any point here and plug also in this. So y prime prime of -3, y prime prime of let's say -1. So plug in -3 here, and we are going to have negative, which is like decreasing. So we are going to have it to be negative, less than 0. And then plug any point here, -1. This is going to be positive. So we are going to have greater than 0, positive, and this will be increasing like this. Right. So this is what you are going to get at the end of the day. So the interval for the concave up will be where the positive sign is. So you are going to have -2 to positive infinity, and where the concave down is going to happen is at where the minus is. So we are going to have from negative infinity up to -2. Does the function have any inflection point? Yes, at x is equal to -2. This is the point of inflection. So at x is equal to -2. Right. If you have time, see if you can sketch. I don't have time. Okay, just kidding. So let's try and sketch by adding all the graph together, right? So we have -2, and then the one that is having this one, we have -1, -3. So -3, -1. We saw that so let me just take this, the whole of this, and just send it down there, and let's just analyze that. Copy, and let's just paste it here so that we can analyze that to sketch the graph. So let's see something here. We can see that at this side the function is increasing from -3 to -2. Actually the function is decreasing, right? And here too is decreasing, because we can see that from -2 to -1 is still between this, right? It's still between this and still decreasing here. Then from -1, this is increasing. So we are going to have something like this. So that is what we are going to get, because from here we saw that from this is kind of like increasing, and this is decrease. So we are going to have it to be decrease. So we can sketch something like this, which is very nice. We can sketch on the x and y axis. We can think of -3. We can think of -2. We can think of -1. And then we can think of, so the minimum value is going to happen at -3, and then this one is going to happen. So let's try and then find a point. What is f of -3 and then f of -1? So let's plug them in. Oops, this is going to be so a lot. So instead of computing, for us to do it, what we just need to do is we need to compute this, and we need to compute f prime of -2 for the point of inflection 2 as well, so that we can get the y coordinate. But I'll just sketch. So we need to have something like this, like kind of something like this. Right. So at this point, this kind of sketch, right? At this point is where the point of inflection is going to be, because that is where x is equal to -2. So a point on this graph here is where the point of inflection is going to be, right? Now remember, at -3, what do we have? We have the maximum. So at -3, we are going to have maximum here, and then at -1, let me just draw my graph well. At -1, we have the minimum, right? But when you find the values for this one will help you to see if the graph is going to be like up like this, or is even going to be something like this below the graph, right? So that's what you are going to get. Now let's look at question 2. Question 2 is saying that find absolute extrema, right? So we saw that we learned how to find local extrema. That is where we have the local maximum and local minimum using the critical values, right? And sketching, checking the sign chart. But let's look at how we can also do this one. Now, for us to find the absolute extrema, we need the max, and then we need the what? The minimum, right? So what we need to do is, first we need to find f prime of x. We need to find the critical values. So what are we going to get from here? This is 3x squared minus 6x minus 9. Let's do some factorization here. 3 out, x squared minus 2x minus 3. This is the same as x squared. So I can write this one as plus x minus 3x minus 3. Good. And this is going to give us 3. When I factor x out, x plus 1. When I factor minus 3 out, x plus 1. Here, when I factor x plus 1 out, what will be left? It will be left with x minus 3. So it's not hard to see that when x is equal to -1, this will be 0. And then when x is equal to 3, this one too is going to be 0. Right. So these are the points that we are getting, right? But what we just need to do is, now for us to find the local extrema, the absolute extrema, we need to check the domain. It's very important. The domain here is very important. This is the endpoint. So we need to check if our critical value or point is inside this one here. So we can see that -1 is not in this, but 3 is in this. So it means that what we just need to do is we just need to extract this x and then f of x. So the endpoint is 0 and 4, and the one which is in between the endpoint is 3. So I just have my 3 here. So I need to find f of 0, f of 3, and then f of 4. Good. So when I plug in 0 here, this is going to give us 11. So it's not hard to see that it's 0, 0, 0. Let's plug in 3. So when I plug in 3, I'm going to have 3 to the power 3 is going to give us 27, minus 3 squared is 9, times 3 is another 27, minus 3 times 9 is another 27, and then plus 11. So this will cancel this, and then this is going to give us, I think, minus 16. Yes. So we need to have this one to be minus 16. Then let's look at when x is 4. Plug in 4 here. This is going to give us, I think, 64. Yeah. So 4 times 4 is 16. 16 times 4 is 64. Good. Then let's plug in 4 here. 4 squared is 16. 16 times 3. 16 times 3, 6, 3, 18, 1, 48. Good. So minus 48 minus 3 times, no, 4 times 9 should be 36. Yes, plus 11. Then let's try and subtract them. So this and this is going to give us 75 minus this and this is going to give us 80, 84, I think. Yes. And then when you do the subtraction, this is going to give us -9. I think so. Yeah. So now let's try and then figure out the absolute max and then absolute max. We need it in a point form, so we are going to have, so the max will be at this, here is where the max is, and then the minimum is at here. So this is the biggest y value, followed by this is the least. So we are going to have 0 and 11, and then the absolute minimum is going to be 3 and minus 16. Yeah, so that's what we just need. Let's do the last one. Same idea, we need to find gen prime. This is 4x plus 4. This is so nice. I factor 4 out, x plus 1. So this one is not hard to see that when x is equal to -1, gen prime will be 0. So that will be our critical point. So, but let's ask ourselves, is -1 inside the endpoint? No. So we just need to pick x and gen of x. We just need the endpoint because the critical point is not in the domain. So plug in 0 here. So gen of 0, what are we going to get? 2. Then gen of 3, let's plug in 3 here. 3 squared is 9. 9 times 2 is 18. Plus 3 times 4 is 12 plus 2. So this is going to give us 32. Yeah. So this is going to give us 32. So absolute max, absolute minimum. In point form, this is the max will be 3 and 32, and then the minimum is 0 and 2. Yeah. So that's what you are going to get. Yes. Okay. All right. So see you in the next video.